Welcome to the problem section for radians and degrees. And again, we're going to do a number of problem sets. First one is find the radian measure when the radius is 3 centimeters and the arc is 9 centimeters. So theta equals arc over radius, so 9 centimeters divided by 3 centimeters. The units cancel out, and then 9 over 3 is simply 3, and then we may or may not write rad for radians behind that. 3 radians, that's pretty close to pi, which means that's about 180 degrees. Obviously, the drawing that I have on the side here is not to scale. Second example, S over R is arc over radius is 3 centimeters over 6 centimeters. Comes out to 1/2, obviously, or 0.5. I think I like 0.5 better. 0.5 radians, that's in the neighborhood of 1/6 of pi, so pi over 6. Pi over 6 is 0.52 something. So we're at about 30 degrees for this one. Okay, next problem set, which says, name the reference angle in degrees and radians for the following. I'm going to save myself here not to draw them. So theta equals 30 degrees. That means that the reference angle is also 30 degrees. And in radians, we're going to come up with, well, 30 degrees is, 180 degrees is pi, 30 degrees is 1/6 of 180 degrees, so it's going to be pi over 6. Next one is 60 degrees, so reference angle is 60 degrees, and 60 degrees is 1/3 of 180 degrees, so it's pi over 3. The next one is 260 degrees is 80 degrees, the reference angle, and then of course this one is not pi over 2, but I have to see 80 divided by 180, so 8 over 18, or 4 over 9, so we have 4 pi over 9. 340 degrees, that's reference angle of 20 degrees. And so 20 divided by 180 is 1/9. So we have pi over 9 as the reference angle. Next one, draw and convert to degree measure. I will draw them in just a moment. Let's convert them first. So I have pi over 3 times 360 divided by 2 pi. You can do that on the side, respectively. It's just so ingrained for me to do this 360 over 2 pi. You can also do 180 over pi, 180 over pi. Either one works. These are so easy that we can do them in our heads. We know that pi over 3 must be 60 degrees. And of course, besides that we have that memorized, of course we can see that the pi is canceling, and then our height is 80 divided by 3, of course, is 60. Pi over 4, well, we know that that is 45 degrees. 2/3 pi, so we multiply that with 180 divided by pi. The pi cancels. 2/3 of 180 degrees is 120 degrees. And the last one is 3/4 pi. So again, we use 180. I guess in the meantime I got used to just using 180 over pi. The pi is canceling, and then 3/4 of 180 comes out to 135 degrees. Let's go over to paint and look at them. And I just noticed that I have something from a previous section on there, so I will save this one here first before I do anything else. Okay, now let's open a new one. Okay, so let's grab this one here. These here, the first one was 60 degrees, or pi over 3. So 60 degrees should be roughly here. And then, of course, we had here 60 degrees. And the reference angle is, of course, the same, also 60 degrees. There we go. The next one was 45 degrees. So we're here. And we have 45 degrees. And of course the reference angle is the same, 45 degrees. Then we had 120 degrees. So roughly here. The way I do these here at these easy angles is that I go back to special triangles and figure out, okay, if I have an adjacent of, an opposite of 3, then the adjacent here comes out to the square root of 3. As we know from special triangles of 60 and 30 and 90 degrees. So here we have an angle of 120 degrees. I actually meant to do that in black. There we go. And a reference angle of 60 degrees. And then the last one, we had an angle of 135 degrees. So there we go. And here's an angle of 135, and then a reference angle of 45 degrees. Okay, let's go to, let me actually save this here before I forget again. There we go. Okay, let's go back to Word. Okay, next exercise, which says convert to degrees. So theta equals 1 radian, convert to degrees, so, and then 2 radians and so on. And again, I may want to switch this here to 180 over pi. As I said, both are possible, but usually trig books prefer the 180 over pi, so I'm going to do that too, rather than 360 over 2 pi. Either one is the same. Okay, let's go over to the graphing calculator and do that. Okay, so the first one was 1 times 180 divided by pi, 57.3 degrees. The next one is 2 radians times 180 divided by pi, of course, should be 114 degrees, 14.6. The next one is 1.3 radians. I'll just use the second entry button. And then I guess it was a 1.3, 74.5 degrees. And the last one, 2.4, it's 180 over pi, 137.5 degrees. plug in the results. $57.3, 14.6, 74.5, and 137.5. Okay. The last problem set here says write the results in ordered pairs. That means we have an equation here, y equals 2 sine x, plug in all these angles here, and these are our typical 45, 30, 60 degree angles, actually just 45, 90 degree angles and so on. So we plug them in. Sine of 0 is 0. Sine of pi over 2, or sine of 45 degrees, is 0.707. So we come up with 1.414, which of course square root of 2. Sine of pi is 0. Sine of 3 pi over 2, which is the same as sine of 220. Let's see, what is that? That's actually 270 degrees. So what they meant to do? Yeah, 270 degrees actually. So that's negative 1 times the 2 is negative 2. And then sine of 2 pi, of course, is 0. And then in just a moment, I'll go over to paint and graph these. Cosine. Cosine of 0, of course, is 1 times the 1/2. There is going to be 1/2 or 0.5. Cosine of pi over 2. Ooh, did I make a mistake a moment ago? I think I did. Pi over 2 back here, that wasn't 45 degrees, that's 90 degrees. So sine of pi over 2 is 1 times the 2 is 2. I cannot go back really conveniently and erase my mistake here. I just have to say, hey, I made a mistake, and now I correct it, because otherwise I just have to do the whole thing over again. So it's easier, much easier to just correct my mistake. So cosine of pi over 2, same as cosine of 90 degrees, which is 0. Then cosine of pi, same as cosine of 180, which is negative 1, so minus 0.5. Cosine of 270 degrees, or 3 pi over 2, is 0. And cosine of 2 pi is 1 times the 0.5 is 0.5. Okay, now we're going to go over to paint and graph these. And with that, we will conclude this problem section. Okay. So the first one for the sine was that we had the ordered pair 0, 0. Then we have a pi over 2, which is 1.57 and 2, so we're roughly here. Then we have pi and 0, so we're roughly here. Then we have 3 pi over 2, which is 4.7, so we're roughly here, and negative 2, and then we have 2 pi, which is 6.28, and 0, so we're roughly here. And as you can see, the sign would be like this here. Not a triangle, but in the next section where we graph, you will see it's a kind of nice wave, sine wave. Okay, the cosine is going to look like we're at 0 and 0.5, so we're here. Then 1.57 and 0, so we're here. 3.14 and negative 0.5, we're here. 4.7, 3 pi half, that is, and 0, so we're here. Actually, not quite. We're here, approximately. And 6.28 and 1/2, so we're about here. And again, the cosine here is not a triangular form, but it kind of looks like this here. nice cosine form. And again, in the next section, we will see how the cosine really looks like. With that, I conclude this problem section for radians and degrees. Welcome to this add-on to the problems from section 3.2. Apparently, when I originally recorded this, I had forgotten a few problems, and the labeling is just slightly off. It's correct in the script now. In the previous eLive, it's slightly off, but here it's correct. So anyway, here are the problems. It says, give the exact value for each of the following. So we're going to go in here, and what is sine of 4 pi over 3? Well, the reference angle is going to be pi over 3. So sine pi over 3. Reference angle score is always in the first quadrant. The angle 4 pi over 3 is in the third quadrant, where the sign is negative, so I'm going to put a minus in front of that. And then we know that pi over 3 is the same as 60 degrees, and we know that the sine of 60 degrees is the square root of 3 over 2. So the square root of 3 over 2, and if we wanted to write that as a decimal, it would come out to minus 0.866, as we have it memorized. Okay, next one. So this is going to be again the same kind of reference angle here, pi over 3, and the cosine in the third quadrant, or I'm sorry, 4 pi over 3 again is in the third quadrant. The cosine there is negative as well. And so again, it's going to be cosine of 60 degrees, which we know is 1/2. So we're going to come up with minus 1/2, which of course is the same as negative 0.5. And a tangent pi over 6. Well, that's already in the first quadrant. So we're just going to determine it. Pi over 6 is the same as 30 degrees. We know what the tangent is of 30 degrees, which is 1 over the square root of 3, which then comes out to 0.577, which we have memorized. And the last problem here, cotangent pi over 3, which is the same as 1 over the tangent of pi over 3. So I could write this here, 1 over, I'll do that in just a moment, 1 over tangent of pi over 3. We know that tangent pi over 3 is the same as tangent of 60 degrees, which is going to be square root of 3 over 1, but that needs to be inverted. So equals, big parentheses, square root of 3 over 1. And as I said, that needs to be inverted. Because of that 1 over here, when we do that, we come up with 1 over pi, of 1 over square root of 3, which of course is 0.577 as well. That's why I copied this one here earlier. And that was problem F, the add-on to the section 3.2, the problem section.